Hello, welcome to the discussion. We'll wait for a couple of minutes, see how many people will be joining in, and then we'll start about this thing. So yeah, I guess that's about it. So hello, Soumya Das. Hi, Devanshi. Hi, Devanshi. And hi, Saket, Aziz. Yeah. So Soumya Das, can you please introduce yourself and let us know what you work on?
Yeah, hello everyone. I'm Soumya. I'm currently fifth year PhD student. Am I audible? Everyone can
Yeah,
just
you are.
okay. So I'm currently completed fourth year PhD in Indian Statistical Institute. I work in quantum information and quantum computing. So when the IBM quantum computer was introduced back in, I think, 2018, so then I started working on this IBM quantum computer. So there was no Q-skit then. There was only a 5-qubit quantum computer, and there was only drag and drop feature. And we have to run the circuit and do the experiment. Then I have performed a quantum protocol in that 5-qubit, which is published recently in ACM Transaction of Quantum Computing. That is the name of the paper, and the link I will share with you. So currently I am also working in some of the quantum information protocol, and one of my paper that is published in Physical Review A. So other than that, I am also interested in quantum machine learning and quantum benchmarking, and I am also working on 2 papers on that field. So one thing I'm going to tell you that the quantum information or quantum computing IBM Q-skit is very much hyped. So, and everyone is working in quantum computing and quantum Q-skit, but you should have a strong background on quantum information and computing before proceeding in this area, because this area is very much far elaborated, and lots of papers are coming in this area. So now working in this area is going to be really hard. So anyway, you go on and learn QSkit, and also I think Rigetti has IBM Quantum. They have some cloud computing. Amazon have the cloud computing source. So don't limit yourself in only QSkit. So go on and explore other quantum technologies also. And if you need any help in any of the technologies, you can contact me. So that's all for my portion. If you need any help in any project in quantum or any kind of thing, so if I can do, I am ready to help you. Okay. Yeah, back to you. Drishyam.
Thank you very much, Soumya Das.
Huh.
Hello, is Shreya in the Shreya, are you in? Just checking. Just a minute. Someone, are there like beginners inside? Like, if you want to say something about where you're starting right now, you can just say. I see Raghav's mic is unmuted. So, would you like to say something, Raghav?
Oh, hi. I am Raghav Shah and I am doing my MSc over in Madras University. So I am kind of like quite interested in this, and I have been like learning since 2 years. and
Uh-huh.
finding out opportunities everywhere. Yeah, like I'm not sure how do I do it,
Uh-huh.
but I'm trying,
So,
and probably like getting this group is a one kick start. So yeah,
yeah, sure, definitely. So you had these courseworks and all in your in your MSc syllabus, like linear algebra and all.
yeah.
You've done
These
those,
courses
or
like
you're yet to
linear
do?
algebra and quantum mechanics were like already in the coursework only, but that is way too different than quantum computing course now.
Yeah, right. Mhm.
So yeah.
And so you began with this Qiskit ever? You worked with that?
Sorry. With Qiskit, I tried to learn. I knew programming and Python. I knew, so I did not go much into it right now itself. Like I did not go into the programming part. I am more interested with the experimental side.
Acha. Okay, nice, interesting.
Yeah.
Experimental maybe. Yeah, a lot of centers are opening up in India. Uh, I heard there is one opening up in
Oh,
Tirupati also.
really?
Tirupati.
Oh.
Yeah. A mega
In
budget, I
Tirupati,
guess.
Isar
Yeah.
Tirupati.
Yep. I'm
Oh,
not
okay.
quite sure when
Really?
it's about to begin, but it's a mega budget thing. And there are more people. Nakul is here, but he's kind of unwell today. Anyways, thank you, Raghav Shah. And
Yeah.
Nakul is here, but he's a bit
I can,
unwell. I don't know if
I
he's
can,
willing to speak.
I
Yeah,
can,
Nakul.
I can speak a little. It's okay. Like,
Right.
uh,
Thank you very much, Nakul. So, just to introduce you about Nakul, he is an engineering graduate. Probably he took a 1 year break after that. So, he's worked extensively on quantum computing, and he has worked on Qiskit and other things. He has won. His team has won a bronze medal, if I believe, in this IBM hackathons or some competitions the IBM they conduct regularly, so you can even find his name in that. Not only that, he has done many projects on that. He has scored like really good in Just Jam, and he is selected to a lot of universities. Currently, he's doing his masters in Alberta University, Canada. So you can ask Nakul about like where he has begun up about this thing, or how to begin with this thing. Since I'm assuming most of you are beginners in this quantum computing, so I can, I mean, you guys can maybe ask him for suggestions and where to begin with, because that's what I see is the roadblock for most of people here, right?
hi everyone. I'll just uh, thank you, Dushyant. So I just talk about some of the things that I did during that 1 year break after my undergraduate. So my work was in variational quantum eigensolver, and in particular, the professor that I was working with. So we developed a technique for finding the solutions to the 3-sat problem, which is a very famous problem in computer science. So we looked at various symmetries of the 3-sat problem, and based on the symmetries, we tried to design an optimal quantum ansatz or circuit, which can give us one of the which can predict for us if a solution exists or not. And if a solution exists for the 3-sat problem, just enumerate one of the solutions. So that was the basis of the VQE variational quantum eigensolver method that I did, and it has been submitted. I have not got the result yet. And the second part that I'm currently working on is, so we are writing a book on quantum machine learning. Um, so uh, that part is still going on. It will take a year or so. And
You're writing
regarding
with your people from that institute, or
so as of now, most of that work is individual, but there is one professor who is involved, and if like right now he's not contributing that much. So if he gets involved significantly, then and if the work gets complete, then we both will share the authorship. Otherwise, if there's not much contribution, then I will go alone in this work.
okay, interesting. Can you tell us where you started your journey in this thing, like when you probably you realized this in your engineering that you want to work in this quantum computing, right? So what were the resources that you seeked, and how do
Okay.
you know about those things? Yeah.
Okay. So the inspiration for this, because my undergraduate degree is in information technology, so the inspiration for working in quantum computing began very early, because there were a number of students that were in my batch that were particularly involved in quantum computing. So from there only I got a head start. Regarding the resources, the very first thing that I did was to watch the lecture series, which is from NPTEL. So there are two lecture series in quantum computing which are given by NPTEL. One is more on the hardware side of quantum computing, and the second is purely quantum computing algorithms. That is by Professor Deepan Ghosh. He's a very famous professor. I believe I'm from IIT Kanpur. Now he's retired. He's very aged. I think around 80 plus. But you can watch his lectures, and the best part about his lectures is that he is giving all the necessary mathematical steps. He's rarely missing steps. And secondly, you can go to his website, deepanghosh.com, I believe, I'm not sure. And in the course catalog, in the quantum computing side, you can find out that he has written all the it is a kind of transcript to all the videos, not the exact transcript, but for all the videos he has provided notes. So based on that, this can be a very good start uh, if you want to learn quantum computing. And secondly, in this direction, so I will discuss there are various aspects to quantum computing, but before that, there's another lecture series from NPTEL, but that is covering various implementations of a quantum computer, and in particular, the professor. I do not remember the name of the professor, and I haven't watched the lecture series myself, so I cannot vouch whether it's a good series or not. But he has covered, I believe, a lot of hardware techniques, like so you have uh, just let me check what all he has covered. NPTEL. I'm not sure whether he covered the superconducting quantum computer, but just okay. So he has covered NRM, quantum computing. I can see he has also covered uh, um, ion traps. I believe it's week 5 and week 6, and after that, okay. So he has also covered superconducting quantum computing, not that much in detail, but uh, some part of Josephson quantum circuits, and that's it. So I believe three techniques he has, three hardware implementations he has covered. But as far as I remember, some of the PDFs that I have seen, so they are very. So he has not derived anything for you. Like you will have to go check everything from other resources. So I'm not sure whether you should watch this lecture series or not. But you can go ahead if you are interested in the hardware side of quantum computing, because this is the only lecture series that you will find online which is covering hardware side in continuation and in detail. Obviously there are other lecture series, for example on IQIM Caltech, and then even Princeton Quantum Institute. So they have, and even Waterloo, University of Waterloo's channel on YouTube. So they have, but they are very specialized lectures. So you just need
So,
to be.
yeah, that's yeah, those will be quite useful, I believe. Probably, I guess we can make a list of these lectures also in some blog or something.
Yes, but there are not many. Like there are 4 to 5 lecture series that are available on YouTube.
We can add the reviews along with them. That would be
Yes.
helpful.
So and regarding books, just to mention, I'm not sure. There are multiple books, but none of the books that are available in the market in quantum computing are good enough. In the sense, some of the books are not covering the entire mathematical um, uh, derivation, and some of the books are not giving you the physical intuition. But I believe the one book that I feel is good enough is Nielsen and Joan. They have covered a lot of material. So, with regards to books, you can refer this particular book, and there are also a lot of online resources. Like Dushan said, we will make a list, like Scott Aronson's notes. There are multiple people whose notes are freely available on their websites that you can
Preskill
also
course.
see. Pardon?
Yeah. Preskill. I mean,
Yeah, Preskill, Scott Aronson,
yeah.
most of the pioneers, like even the HQL algorithm, all those people, Harrows, they have their notes available on their websites.
Yeah, someone's asking what about Aizen Sean Peter Short's course, Rishi Tiwari. Maybe Rishi Tiwari will we'll get to that in the group maybe, because this wasn't about the resources precisely. So we have two more speakers and we'll let them say something. So Amitabh Yadav, I think you have mentioned somewhere. Thank you, Nakul. So I'll get back to you. Amitabh Yadav, you have mentioned in the group somewhere that you are doing your masters right now, right? If I'm not wrong, I'm confusing with someone else. Can you just
Yeah, hi Dushyant,
say hi,
and
Amitabh.
hello everyone. So, actually, I finished my masters. I finished it last year. I was like initially I did my bachelor's in India in electronics engineering, and then I specialized in quantum computing from TU Delft. So that was like my first introduction to quantum computing. For like I did a couple of courses and did my thesis in quantum computer architecture design. So like my specialization I would say is more towards the hardware aspects, like specifically building control hardware for quantum computers, and like because it's so tightly packed and the layers are not separated, so you actually need to take care of a lot of consideration going on the on the physics side of things in order to design a proper compatible hardware for your quantum processors. And like for last 1 year I've been doing like quantum algorithms, like specifically pattern recognition related applications, basically investigating whether any if we can achieve any speed up on circuit model using like quantum techniques for pattern recognition. So yeah, that was like briefly what I do. So yeah, in like I can probably help with a number of questions related to like both of these topics. I would say. So I see there's a question. I have a
Yeah.
question. Okay, so it's about physics, right? So if you want to apply to a physics graduate program, then like what kind of work you need to go through? So yeah, you'll be at a slight disadvantage given that you don't have a physics background, because even if you
Amitabh, you muted yourself accidentally, Amitabh. Hello. Can you hear me, Amitabh? Amitabh, hello. You have accidentally muted yourself. We can't hear you.
hello.
Yeah, we can hear you now. Yeah. You were
Oh,
muted
okay.
for a minute.
Oh, I'm sorry. Yeah, so there was a question that like you'll slightly be at a disadvantage, like given that you don't have a physics background, because they expect you to know a lot of other things beside quantum mechanics. So I would say that like in your bachelor's program, if you have an option to do electives, then like definitely go for like at least the major electives of your physics program in order to just satisfy a particular constraint. But this is not like a very hard requirement, in the sense that suppose if you're applying for a physics program in the US, then you need to also give the GRE physics exam, and like since you have already given that, then it sort of qualifies you to apply to the physics program. So like, having a good score on your GRE physics subject test is one of the requirements. But if you're applying to Europe, then things are different. You like don't necessarily need to take the subject test. You can like directly apply for like during the deadlines, but you need to have a master's as well. So either the easier way to do like proceed into physics is to apply to a physics master's program, get selected in that, and then apply for a PhD. And US offers you the option to directly go for a PhD and skip the master's, but you need to take the GRE physics test.
Yeah.
So
Yeah, continue, please.
yeah, so let me just take the first question. That was like, what was the views on Peter Shor and Isaac Chong's course on EDX? So I did that course. I haven't completed like all 6 parts, I believe it has, but like initially I took a number of courses. It's quite detailed. It helps you develop an intuition, but it takes a lot of time as well. It's not a quick course. It's like a regular classroom course. So if you're going for that, like you'll definitely develop an intuition for like what's happening specifically at the algorithmic level. Like you should try to get an intuition when you are doing basis changes or when you're doing rotations using gates. Then it will help you develop an intuition if you do that course. But yeah, it takes a lot of time. It's good though. And yeah, and like Nakul and everyone else mentioned, there are a number of courses, and there aren't any go-to books right now in quantum computing. Like you can just read that and like learn everything about specifically hardware. Like for theory, you can find a lot of things. Like the Nelson and Chuang is definitely the first book you should pick up. Then if you want to specialize, then there are other books on quantum error correction. I believe it's from professor from USC. And yeah, there's if you want to go into communication, there's another like a really good, I think, quantum and classical information theory, something like that. I think quantum information theory, Mark Wiley, I think it's his book. So those are some good books. And other than that, if you are looking into hardware, then you should definitely refer papers. Like try to find which are the groups specifically working. Suppose if you're looking for superconducting qubits, then there's a professor in ETH Zurich called Andreas Wallraff. So Andreas and Alexander Blaise are the 2 guys who actually gave the theory behind the superconducting qubits. Like how a superconducting qubit should be designed. So those like papers from those guys are definitely worthwhile reading. And yeah, so like try to find whichever group, like whichever field you are interested in, try to find the professors who are working in that field and refer to their group's papers. That would be a much faster way to know things and like what's happening every day. And like I think everybody posts on archive, so the PDF is readily available for free.
All right. So members, if anyone is worried about they have noted down all these things, don't worry. The call is being recorded, and at the same time, we'll probably get the speakers to make a list of the references that they have made. You'll get a PDF or something like that. We'll make sure that will happen. So don't worry about that. And coming to Amitabh, yeah, thank you very much. So where did you say you did your engineering from?
So my bachelor's was from a university in Dehradun. It's called the University of Petroleum and Energy Studies. Yeah,
and so what was the first step that you've taken into this field of quantum computing, apart from the courses that you've done and the electives that you've chosen? What was the first internship or some informal work that you've done? How did you go about that?
Okay, so like I would say my first experience was during masters. So when I applied for masters, like in my application form, I didn't mention that I want to pursue quantum computing. But like when I reached there and like there was time to take courses, then I thought like it'd be interesting to do the first course, and then I did the first one. Then I found it interesting, so I just continued on that track. So I think we had 5 courses related to quantum there. The first was like Introduction to Quantum Information, which like easily can be substituted by the EDX course by Peter Shaw and Isaac Chuang. Then the second course was Quantum Communication. So this again can be substituted by, not substituted, this was exactly the course that runs on EDX by Stephanie Weiner and Peter Vidic. So Stephanie Weiner was our professor who actually taught us the course in the university. So even that is available online. Then third was quantum hardware. So that was like what happens at the physics level. And the fourth was quantum electronics, like basically the classical electronics that you use to design like quantum hardware. Even this is available on EDX. So there's a course by TU Delft. I think it's called The Building Blocks of Quantum Computer, something like that. So like you can follow even that course and you can get a good intuition. And for quantum hardware, you can find the, like Nakul mentioned, the NPTEL course that can give you a good idea of how the physics in the hardware happens for different technologies like the ion traps or superconducting or spin qubits.
Thank you very much, Amitabh. You got something to add?
Oh no, like that was mainly it.
Right. Thank you very much. We also have Devanshi Arora with us. Hey, Devanshi. So Devanshi has, from her LinkedIn profile, done like 4 or 5 internships in multiple places, and she has a very nice curriculum today, and she has done maybe she has also done some projects and maybe published also. Welcome, Devanshi. Like, can you just briefly introduce yourself?
Hi. I want to start with a brief introduction about myself. I did my bachelor's in electronics and communication from SRM Chennai, and I completed that in June this year. And I started learning about quantum computing, to be specific, from Qiskit last year in September. And after that, I also did an internship with Q World in January, February this year, and also continued that in June. It was based on a project named as Solid State Quantum Circuits, in which we actually worked on this. Hello, yeah, am I audible?
Yeah, you are.
Yeah. So I was just saying that I worked on solid state quantum circuits in basically on superconducting quantum circuits, and as you mentioned that I did publish a paper. It was based on software mitigation of software mitigation and error correcting techniques using Qiskit again. So so these were few projects I did in past, and right now I'm working on this project of Q.js, in which we are working on making a circuit designer similar to what IBM people have. And I'm just working on open Q circuit models.
Nice. And one more thing, it says from your profile that you worked as an intern in some company, right? Some India's only quantum computing company, as I know, right?
It's Quantum Computatio, there I worked last year. We only worked on this Qiskit and one more, their own simulator known as Monte Carlo. Just basically I started learning quantum computing in that. So soon I left that, and because I had to complete my bachelor's, so I soon left that company and I joined this company known as not exactly a company, but a research organization known as Quantum Computing UK, in which we are writing a book on Qiskit and how to use Qiskit for various projects and how can it be used for quantum machine learning. Along with that, we published a paper on software mitigation schemes, as I just mentioned. And so these are few projects, and right now, just last week I started my master's in quantum physics and quantum hardware from Japan, Shizuoka University, and right now it's online. So
Yeah. And so, what was your first step into this? You started with Qiskit,
I
and what was your
started
first?
with Quiskit textbook available on IBM site, and along with that, I did two ADX courses named as Hardware of Quantum Computer and Introduction to Quantum Information Science. So this took me around 3 to 4 months. After that, I read one normal primer on quantum computing. I don't remember the author right now. So there was this primer on quantum computing, and I kept on attending some series, some sessions, workshops on quantum computing, and did some projects like as I said. So yeah, this was, and then
So,
that's when I started that I'll do my masters in that to get some specialization and do some good projects. So that's what.
so what was your projects, and what was the first one, and how did you approach a pro for somebody to get the first one?
Yeah, so there was this it was an happy accident actually. On LinkedIn actually helped a lot. There was this the founder of that UK organization I'm working with. They were discussing some error correction schemes on some project on LinkedIn. So I hopped on to that discussion and we started discussing on a common technique we can approach or we can make for that particular problem. So that's how I got into that organization and that's how we worked on that project. So that was just an entry for me for that project, and that's we also we are working on some optimizers from that. So one thing led to another. So that's how I started. Basically, just right people, right time. That's what.
Yeah. I'm sure it's
So
not really an accident as
I
such
don't think
because.
so. Like according to me, I might be wrong. I don't think so. Like but you need a particular physics background to get into something you think you can do better. So just read some things or read some books, do some projects. Like it's not compulsory to know even quantum computing to get into quantum computing. To be honest, like if you know Python, you can understand Qiskit, and if you know say machine learning, then you can learn quantum randomness, quantum generation, quantum portfolio optimization. So I guess if someone is, and if you know Node.js, you can learn Q.js. So it's not compulsory according to me. Like I'm not experienced that much right now. So according to me, it's not compulsory to get to know physics, to have physics bachelor's degree or get into physics to get into quantum computing. So
Oh, your thing seems to be more into the computing part and the coding part as such, or algorithmic part, if I'm not wrong. Is it so?
yeah, right now it's that.
Yeah. So then, yeah, I mean, it's kind of interdisciplinary thing
Yeah,
as such.
someone has to be
So,
like there are two types of people. Someone is a theorist or one are experimentalist. So if one has to be a theorist, then I'm more into experiments. So if one has to be a theorist, it has I think that person has to learn more about physics or into theory and all that.
interesting. Yeah. Thank you very much, Devanshi. And if you have time, I would like to request you to write a small blog post about where you started about your journey. It need not
Yeah,
be in our
sure.
blog; it could be your LinkedIn or anywhere. Just share
Yeah, I
it with
am
us.
in medium. I can write down.
Yeah, that's interesting. Thank you very much, Devanshi. And
Thank you.
who else do we have here? I think Aziz. Aziz, I heard you're also doing a project, sorry, master's somewhere, right? If I'm not wrong. Abdul Aziz. Hello, Aziz.
Hello, can you hear?
Yeah,
Hello.
you're audible.
Okay. Currently, I'm a senior undergrad, final year engineering student from VNIT Nagpur, and my stream is metallurgy, material science. But but I want to when I was in first year, I met one professor at my institute named Ram Kartik. So he actually initiates the quantum computing club in our institute. He even has started he has his own lab which was funded by government in related to quantum computing and condensed matter physics. So he was my tutor. He was my tutor for physics course in the first year. So this is how I actually met him, and later on I prepared for JEE Mains and JEE Advanced, and that time there is a hype to go to IITs and NITs. So in the same way, I went to NIT. I took admission at NIT. Later on, I find that oh no, I should have taken the pure sciences, either mathematics or physics. So actually, but as I have already taken admission in engineering, but I have to go into physics, and I found this professor. So he actually helped me a lot learning quantum mechanics. I actually attended his lecture at for MSc course. In at VNIT we don't have BSc yet; we have MSc. So actually, I used to attend his lecture there at VNIT for quantum mechanics and different physics courses. And I have for a winter vacation for about 1 month, and summer vacation for about 3 months. I stayed there and worked with him on various fields like quantum error mitigation, and one more thing I have worked under him was not related to quantum mechanics. It was related to relativity and gravitation, general relativity and all that other things. So this is how my journey has started in physics, and that time I decided that I have to attend the graduate school. Obviously, I won't be pursuing engineering later on after completing the bachelor's. So the during this lockdown, someone has messaged me about the IBM Qiskit, and this is the first time that I heard about Qiskit. I have never learned anything related to quantum computing. Before that, I heard about Qiskit and IBM. But in this July and August, these 2 months, I really worked hard to learn Qiskit, as well as I have taken some courses on Coursera as well as on EDX, and then, as well as I use MIT OCW, Open Courseware. So these things have actually helped me to understand what actually the quantum computing is. Now, as I have already worked in physics, many different physics areas, and also the quantum computing, now I have decided that the quantum gravity, like it's a part of the pure physics, the relativity and gravitation, and the quantum mechanics. These things, when we combine, is there is a string theory, namely quantum string theory and quantum gravity. These things that I actually find very interesting. So I will be pursuing in this, and currently I am doing one small project under that professor to gain more knowledge related to quantum gravity as of now. So if anyone who is a beginner in this course, so or he's not a major in physics, or he's doing something else and want to switch to physics, so I will tell to them that yeah, you don't have major in physics, so you will have a slightly you will be at slightly disadvantage, but you won't be getting any like this is not like now you have taken this course, so you won't be getting any chances. Like you will getting different opportunities as well, but you need to work hard. You need to approach to the professor so that they can recognize your work, and they can give they can just not appreciate you, but they can recommend it. They can recommend it you to for the graduate school as well, so that you can get a better opportunity to pursue what your interest is. So this is all about, and this is I want to say that that's it.
Thank you very much for joining in. And yeah, so anyone else would like to say something? Hey, Ankul is here. Ankul Prajapati, hi.
Hi, Dushyant.
Yeah, hi. How
Hi,
is your
everyone.
time?
Yeah, nice. Not very good.
Achha, so you begin your masters already?
Yeah, I begin already have completed 1 month online. Due to some documentation errors, I didn't go there. Maybe the last week of October, till last week of October, I'll be there.
All right. Thank you for being here. So, could you share us like where your beginning point of research, or if you began about projects or whatever?
Okay, nice. Thank you. Hi, everyone. I am Ankul, and recently graduated from NIT Surat with Mechanical Engineering Department, Mechanical Engineering degree in 2020 itself. And yeah, currently I am doing a master study at Sorbonne University. Previously, it was known as University of Marie Curie, and this course is a joint course with the University of Paris and Sorbonne University. And in second year, I have choice to specialize in quantum devices and particle physics and material science with Ecolofall technique and particle physics has a collaboration with CERN. So this is how the structure of my master course. And about my research work, mainly my interest is in quantum hardware and mainly the spin-based systems and its decoherence control. So basically, till now, I've been working on a spin-based system spin-based qubit and how we can use it for the application in quantum sensor and other quantum engineering applications. And about research, since when I was in second year of my BTech, I started exploring the field of quantum technology, and I come to know about these are the some problems and where I can work on. So I found quantum decoherence is the only where I can do something new. So from that time only, I started working with the Q-tip. So everyone here shared about the Qiskit and IBM experience, but till now I haven't much work on Qiskit and IBM experience. Till now I've been working with Q-tip software, and Q-tip is basically similar to Qiskit but more advanced to open quantum system. So Qt provide mainly the inbuilt libraries and tools, quantum tool basically, to solve the open quantum system, quantum optics based system, and either you can design also the circuits and simulate them on your laptop or software anywhere system wherever you find convenient. So mainly I worked on Qtip, and in my bachelor I did intern at IUCA. That intern was mainly was in quantum optics part, in elastic and elastic scattering application in astronomy and astrophysics. And mainly quantum side research I did independently and published a few papers also. Two are in quantum decoherence part, and three are in quantum dot based solar cell, and other are in engineering application. I did my mechanical engineering, so I worked on also CFD and cryogenic systems. So these were the my research experience, and till now whatever I did, briefing of that.
Thank you.
Yeah, thank you.
I forgot to introduce Ankul. He's just graduated from SVNIT, and while he was in second year, he founded this research organization called BoseX, and it's just few engineering graduates. It number started with a few members, I guess, and it's but they did a significant amount of work, and they published in a lot of papers. Like I think they have 7-8 publications. I mean, this is all just engineering grads working in physics and related streams, I believe. So it's a really great achievement, and I would like to if there are someone who is in their first, second years, I would like you to know that just such things are possible. Because when I was in engineering, these things seemed very much impossible to me. So I would like you all to know that these are very much possible. Doing research and all while you're in engineering, and gathering people around you who are maybe it could be from your college, from your class, or even from your town in the neighborhood colleges and all. You could form probably some groups. You could just find people who are in your surroundings, and if you could physically get to meet somewhere, of course, after this corona thing ends. So that would be very helpful and productive to you. And if you could form research organizations or something like that, that would be extremely useful, both in your to add in your CV and also to keep yourself motivated to get some productive work done with some team effort. Uncle, is there? Would you like to add something?
Yeah, basically, I forgot to mention about BoseX. So basically, BoseX is the only thing which I have to discuss about to everyone, whomever I met. So basically, BoseX is we are trying to build as a platform for multidisciplinary research, like kind of physics, chemistry, mathematics, and emerging technologies in under engineering domain also. So when I was in second year, I started like a small group with the motivation of participating in an international competition and national competition. So I thought like let's have some small group, and the group should have capacity to participate in all type of physics under physics domain, international and national competition where we can participate and do something interesting. So like Olympiad kind of thing. Like I had studied like Einstein had also some kind of group, and
Uncle,
Silicon
just a
Valley
second.
was.
Sorry, hello, Uncle. Just a second. Sorry to interrupt
Hello.
you. I don't. Yeah. I am afraid there's. I'm not sure, but I guess there is a time limit of 1 hour. If such a thing happens and the call gets disconnected, you will find the link to the next meeting in the WhatsApp group that you have come to. So yeah,
Okay.
I don't know
In
for
Google
sure if
Meet,
there is one.
in Google Meet, it doesn't end. In Zoom only it ends. In Google Meet, we can indefinitely have the meeting.
All right, all right. Because I read somewhere that there is a 60-minute limit, but just in case. Yeah. Continue, Uncle, please. Thank you.
Yeah, so I was telling about some grouping things. So yeah, the Silicon Valley was also started like this. So I'm not saying like we are going to such build such like in future we can, but definitely research is all about the collaboration, not about the competition. There's two C, and we have to be collaborative, and like once we form some group, we have some also like extracurricular development, like all kind of developments you have as per individual, and you do research in group also. So in future, like when you go for PhD, so you don't will be provided some spoon feeding guidance and all those things. So you have to be independent researchers initially. And if you have some experience at your undergrad itself, then definitely it will add to your PhD time, and definitely you will be working on some core research rather than like wondering about the how you can do some literature survey or some review or some basic skills you definitely will have once you go through these processes. And I have already written about these things, and they are available on BoseX blog post also. And yeah, and we have been working on different projects also, like under quantum domain, under astrophysics domain, under engineering domain, and under renewable sectors like renewable and sustainable development. So here mostly the quantum interested participants are. So like I'll discuss about some quantum projects. So I think Dusant had already shared some Google form, and we already discussed about the BoseX projects and all those things. So yeah, we have also like till in present we have been working in 7 projects, 7 quantum projects. So those are in some of them are in quantum computational part, some of them are quantum circuits part, and hardware research like computational work and theoretical work. And Devanshi is also part of that, and he's currently working in open quantum circuit, and that project was also initiated. Like idea was have like we have a two-way system. Like if someone has experience of some research work, then they can join us as a quantum mentor. And if someone has want to join or like do some research project in UG, or like they have less experience, then they can join us as a member. So they can work on some collaborative platform, or like regardless to their curriculum, and regardless to their background, or they can go work on their interest. Yeah, sir.
Right. Thank you very much. I'll so let's ask some of our members. So let's say Shreya. Hi, Shreya. You're in.
Hi. Yeah. So
Hi, Shreya. Can you please tell us what your background is here, and what your current knowledge about quantum computing? I'm assuming you are basically a typical case where you're in engineering and you have like just begun about this thing. So if you could just let us know what it is, we can ask for suggestions from members who are experienced already.
yes. So I'm in third year I'm doing information technology in Pune University. So I started with this Qiskit textbook. After that, I did the course on NPTEL, and I did a course on Coursera, but I found the maths to be quite hard. The course by St. Petersburg University. Apart from that, I've been learning about a few algorithms and trying to implement some very basic algorithms used on the Q experiencing IBMs. Yeah, and I've done a lot of machine learning in my second year, so I hopefully want to pursue QML. I wanted to know like if it's possible to get internships after third year, like with my background. Like I actually have no background in quantum computing, so yeah, so that's what I wanted to know.
Right. Thank you very much. So yeah, we have Ganesh here, and someone here. Can you suggest something to Shreya or any other person with the same question? Thoughts.
Like there are a lot of internships, and so there are two kinds of internships, particularly in India, in regards to quantum computing. The first one is working in a company. Currently, Adobe, the Delhi office of Adobe and Microsoft office from all over India, they are having small teams which are working in quantum computing. You can definitely apply there. The interview process is very simple. So there are, I believe, 3 to 4 famous companies that are currently working. They've just started working in quantum computing in India. And the second way of internships is working with professors. So my break here also, I worked as a research assistant with a professor. So you can also write to professors who have open positions. And if you have relevant work, it does not matter that much that I've seen in quantum computing, then you can definitely get an internship. And in regards to internships abroad, so most of the companies, quantum computing companies, are from US and Canada, and their requirements for most of them, I know for one bit, even for IBMQ, their requirements are that you have to be either US or Canadian citizens to get an internship. But they have other um, programs in which you can apply, but they are mostly workshop come programs.
All right,
Okay.
thank you. And
Thank you.
also, you can hold my professors. I've also written a blog post regarding how to approach professors for these unofficial project positions, or I mean, not through official portals or something, but there's always like you can go with the prof and you can regularly be in contact, do some project with them, or internship sort of thing. It could be just in the summer or your winter vacation, or it could be a longer duration throughout your semester or something like that. It comes down to how well you present yourself in front of the prof, and how you show that you're actually interested in that. So that requires you to show them that you've learned so and so, and you've done so and so work. So I guess I've elaborated on all these things in my blog post. So I think Amitabh, like, would you like to add something?
Yeah, actually, that was a very good point that you raised, that it all comes down to how well you present yourself. Like, so you basically need to be aware. So I'm not like very much aware what's happening in India, but I can talk about with like a number of applications that you can do for foreign internships. So first thing is that if you're applying to a professor, like he wants a longer duration, like funding you for 3 months is probably not it. They won't be very excited to to have you for a short term, because that would be like quite less time to learn and to actually contribute something. So I know for a fact that there are some universities in Europe, for example, the Quantum Device Lab in ETH Zurich. So there are always open positions for bachelor's and master thesis in quantum group. So you can apply to that. You can write to Andreas Waldorf's office, and you can also write for like specifically try to like do for a little bit longer term. 6 months is, I would say, is a is a decent time frame. And in the US, if you're looking for, then there is a very good summer school that happens in Los Alamos National Lab. And so that's a summer school, true, but in the end, they have a very good project that you actually work on, like with some of the giants of the field, and you actually go into the depths of quantum computing. So that's very good. And you can also apply to Waterloo. So Waterloo also has these summer schools as well as project combinations. And in the US, the national labs, specifically the Brookhaven National Lab, and there is the Lawrence Livermore National Lab, Lawrence Berkeley National Lab, and there's one with that collaborates with MIT. I forgot.
Amitabh, you've muted yourself again. Hello.
Hello. Yeah. Sorry.
Yeah, you're telling about some MIT collab lab.
So there is a national lab that collaborates with MIT a lot, and I'm forgetting its name. Right. I'm just checking 1 second.
That's fine. Maybe you can give the list later.
No, Lincoln Lab, MIT Lincoln Lab. So like those places have very good quantum programs. So if and national labs are always hiring, like literally you can just write to the scientists, and like if they think you are like you fit up with the group, they'll definitely call you for an interview. So it's short, like it's sort of an easier way, and they pay you as well as stipend, so you don't have to worry about that.
Yeah, nice, interesting. And yeah, hi Ganesh. Ganesh is here.
Hey man, hi. Can you hear me?
Yeah, we can hear you. Yeah, so Ganesh is an engineer, was an engineering graduate. Later did his masters in Hyderabad Central University. Is currently doing his Ph.D. in HRI Allahabad, which is one of the best schools for quantum computing. He's doing his PhD under Prajapati. She's the first female Bhattnagar Award winner in India. And so, yeah, Ganesh, so could you tell us about what you're working on, or if you have suggestions for the beginners in this group who are in their engineering stages? What would you suggest?
Yeah. So my work essentially is how to implement. This is essentially what I do is theory. It is quantum information theory, not bits and parts of quantum computing is involved, but essentially what I do is quantum information. And one way of one research area that I think of is how to implement these algorithms that have been designed in real physical systems. That, for example, right now I'm working on how to implement variable range interactions in trapped ion systems. How can we simulate that, and or what noise essentially contributes in a trapped ion system. And so this is the specific topic that I'm working on. And the niche topic would be the broader area is essentially how spin systems behave and how quantum information can help in understanding their phase diagrams and such things, and the other way around also. How can we think about spin systems which are implementable in trapped ions and ultra-cold atoms have their condensed matter properties but enhance quantum information theoretic quantities like entanglement, discordance, and etc. So that this is a two-way street, and I'm trying to understand which way I'll fit in. I'm in second year PhD right now. I mean, if you want to understand more, like what exactly is the area of how HRI quantum information theory works, you can look up scholar pages of Aditi Sen or Ujjwal Sen and even Arun Pati. So they definitely. This is the broader area of work of both Aditi and Ujjwal. Arun works on a more mathematical topic. So if you just go to their scholar pages, you will understand what exactly is happening. For a beginner, I think this should have been discussed, but I'd like to emphasize on the fact that quantum computing or quantum information theory is probably one of those, I don't know, I don't know, I'm not even sure if this such thing exists in the fact that you don't need a strong mathematical quantum mechanical background to start off things. You just need to understand. I think I came late. I apologize for that. So that's why I'm maybe repeating myself. So someone, when I just came in, was asking a question, IT third year, and is it possible to get in? Yeah, so this is why I think this area has become so popular, in the sense that you don't need to have a hard physics degree to get started off in this. So you not even a complete one semester quantum mechanics course is required to do quantum information. Just that you need to know some parts of essentially you need to know the second chapter of Nielsen and Schwang. If you are able to go through that and understand what is required there, you should be good enough to start off on any protocol or any algorithm and start with these things. And the community is built in such a way. This is one of the very, very big plus for this side of physics, is that a lot of people who are doing very, very well are outsiders. Even the foundation fathers like John Preskill or the IQ's director, Raymond Laflamme, they are all outsiders in the sense that they did high energy theory and they came to do quantum information. So it's a huge culmination of engineers, physicists, and chemists and mathematicians. In this, that you don't. So a lot of us in this group want to become physicists from engineers, but there is an opening even for an engineer who wants to be an engineer to survive in quantum computing. So there are so many things to explore and so many things to understand in this. So one will definitely fit in if they just understand these basic concepts. So my suggestion is start off at least finish off first 3 chapters of Nielsen and Schwang. Start along with John Preskill lectures. That Preskill's lectures are intimidating, but start off with that. And this this summer school, Kids Summer School has happened, and they put up the lectures. The first 3 days of what has happened, not even the entire 2-week lectures. The first 3 days essentially covers what fundamentals are required. And if you are able to digest that, then yeah, you're good enough. You don't need an MSc degree. You don't need a physics classroom to understand what is happening in quantum computing. Everything is bare bone linear algebra mixed with a bit of fancy physics. That's all. Everything else is absolutely doable for someone. If you take an example of an outsider still surviving, still trying to understand and growing up, there is a YouTube channel called Quantum Intuition. If someone can look it up, there is a YouTube channel. That guy, I think he's an IT developer by day, and he is able to do things on himself. That is the YouTube channel, the unique selling point of it. So this is happening, and a lot of people are doing it. So you don't need to do physics to survive in quantum computing. So just need to do bare minimum physics to survive in this. And
Right.
probably the field
Just
is
a
going
second,
through.
Ganesh.
Yeah.
Ganesh. Yeah, we have Rahul joining us with us. I forgot to mention his name earlier. I'm really sorry, Rahul. So, Ganesh, if you may allow us, I'd like to start a small chat with Rahul, if you don't mind, because he's been on call for a really long time. Hey,
Sorry,
Rahul.
my bad. Yeah.
Yeah, hi. Please introduce yourself. Yeah, I'm really sorry. I apologize for forgetting your name. Yeah.
That's no issue, sir. I'm Nakul. I did my bachelor's in mechanical engineering in Tamil Nadu. And I've been admitted
Rahul, I'm afraid your voice is a bit cracking. Could you move to a place with a better internet connection?
Yeah, I'll try. Uh, am I audible now?
Yes, you are. Yes, you are.
Yeah. So, uh, would it be all right if we could have it like in a couple of minutes? Maybe I can get into a place where the internet connection is a bit better. So, I'm sorry.
Yeah.
I'm sorry for interrupting.
That's okay. Yeah. So, yeah. So, anyone would like to introduce themselves, like, quick, please, like, just in a couple of minutes. Divyanshu Singh, hi. Hey, Divyanshu Singh, you're there?
Yeah, I'm there. Yeah.
Yeah. Please introduce yourself, man. Let us know where you're
Oh.
beginning right now.
So I am Devanshi Singh. I'm a second year BSc undergrad. So I'm doing physics honors in Noida. I have I don't have so much experience in quantum computing, but actually I have started in July this year, 2 months before. That's it, I think.
You've started some quantum mechanics course you must have had already, right, in your bachelor's? And I
No, I
suppose
don't.
you worked on Qiskit already.
Actually, I have worked with Qiskit only. I have no courses on quantum mechanics because it comes in third year, I think, in BSc honors. So
All right then. Wait for a second until we could get a good internet connection. Yeah, and also I'll be asking people, if you have something to note down, please note down somewhere, or just take some points which we would like to ask the speakers again about, like, let's say, references or references, whatever they have suggested. I'll be asking them to make a PDF or something. If there are other things which you'd like to. Yeah, Sanket.
I wanted to ask whether I wanted to start from quantum computing. Currently, I'm just doing coding. My college is not started yet. So I was learning coding and I just saw I'm pretty much interested in physics and I'm quite confident I will pursue physics. But I want to explore the area. So I got introduced to quantum computing through a friend who is in ISI Berhampur. And he did an internship, an online internship under a professor of ISI Kolkatta. But he did not learn much. He just explained me what quantum computing is. And I got interested and I wanted to pursue it. And the blog has everything. So I want to start from scratch about quantum computing. So what is the process? Should I do a course on Qiskit or an NPTEL course or read a book?
actually, I think I can answer this. So
Yeah, tell me.
yeah, so it depends on you actually, because if you want to start with Qiskit, then you can also start. If you want to, like Nakul have said, that if you want to go through the NPTEL lectures, then you can also do that. Do whatever you want. So I think that will be the great start actually. So
Yeah, rightly said. It depends on your field of interest, whatever you're interested in. If you're more into the coding part of it or something like that, then you can go start begin about with Qiskit. The textbook is good enough, I believe. And as you've seen, Devanshi Arora, she has started with the same thing, and she's doing quite well as of now. She's got 1 or 2 admits abroad. She's currently doing her masters, and that's where she begin about. And if you're interested in, like, information part, maybe you should look into other lectures. And if you're into quantum implementation of quantum hardware, then that would be a different thing. And so, yeah, I'll ask the speakers to get this, make a list of resources that should give us a nice starting point. And at the same time, I would suggest you to be in touch with profs anywhere in your local or outside, via mail or something. It's advisable that you actually go physically meet the profs. Right now, it may not be possible, but you have lots of time, right? So you could just keep mailing the profs one day or the other. And believe me, when I see this, every professor reads every other mail. They just seem to be like not reading mails, but they just ignore them. They just I mean, just from subject line or something, they just know that it's not really quite interesting to them. They just ignore that. So you could keep mailing the pros and maybe ask for a meeting, and in your mails be genuine and mention your whatever work that you've done already, because it can't be like, hey, I want to start this thing, can you help me out? Then obviously prof wouldn't have much investment or much interest in, to do in that, right? So you could start a little bit working on this, like maybe those courses that these people have suggested, right? Courses or the textbooks, whichever they have suggested. You can begin about with starting few chapters of them, and then mention that, sir, I've read so and so. And also, it's better you mention the work that they have done. Go through the work. So if you find them interesting, you could suggest, I like the specific field that you're working in, and that gets a lot of brownie points actually, because that will garner their attention. That will let them know that it's not a generic mail that you're sending just to anybody. Not that you're just shooting out mails, but you're particularly interested in them. And the more you contact them, in the sense like it's always better to go physically meet them. You can ask for them for a meeting or something. Actually, that it's not really difficult. That many people will be very friendly and they'll meet you. Actually, if there is some if you're in some city or somewhere, if there is a research institute nearby, just ask them for their free time, and you can just go there maybe, and then just meet them, because that will give a good impression to them, showing your work conviction. So that's how I would say start. And yeah, that's pretty much about it. Rahul, like, you had a good internet connection, yeah?
Yeah, I hope I'm audible.
Yeah, you are. Yeah, you are. Thank you very much.
Yeah, so I'm sorry about that previously, but so as I was saying, I'm Rahul. I have a bachelor's degree in mechanical engineering, and this year I'm starting my master's in computational science and engineering. And for those of you who don't know, it's a course that's largely related to developing the mathematical methods and, of course, the code for system simulations, regardless of the state of the system. So I got into quantum computing because of the case with Global Summer School. I wasn't able to participate in Global Summer School because I happened to stumble upon it only on the last day of registration, which, well, when I started to register, it was already closed. So, but I've been following it on YouTube, and I've been following it on the QA community. So yeah, so pretty much that's all about me. And I'm really interested to pursue research, but if you'd ask me if I have a specific field, I'm not really sure. I'm still exploring, and I'm really looking forward to making the most of this community. Yeah.
Mhm. Yeah. Thank you very much for being with us. And where did you say you're doing a master's from?
Yeah. So I'll be starting it around about next week.
Where and which institute?
I'll be starting my master's in the Technical University of Munich.
Okay, that's in Germany, right? Mm-hmm.
Yes, that's right. I'm sorry about that.
Yours is not a physics course, but a computational thing, right? You're saying?
Yeah, right. More of applied math and coding. Yeah.
All right. So you have some professors over there who are working in this particular field?
Yes. There's actually the physics department of the TUM actually has a comprehensive quantum computing program. I've been looking at the electives, and I'm really interested to take a course there. But meanwhile, I've also been studying the Nielsen Chuang. I haven't really gotten far because I only started a couple of weeks ago. But nonetheless, yeah. And to answer your question, yes, there are professors who are working there. In fact, there are people in. Yeah, please.
Yeah, your voice was a little bit cracking here and there, but anyways, thank you for participating and letting us know about it. Yeah, I hope you could do good collabs with your profs, and you shape your career into quantum computing. And Ganesh, sorry for blocking you for so long. Please continue.
Okay, I forgot where I was, but anyway, yeah. So you essentially, if you have a hold on so I saw the question by Devanshi, what skills should be developed or necessary for getting internship specifically? Yeah, what Dushan said, that is, you have to stroke their ego, especially if you're going after a professor. That is, you tell that you read their most cited paper and say that, yeah, I'm interested in this area, and that is one good way of getting their attention, and they might read the email. And the second thing is, you should be at least strong with basis. You cannot go there and say that I don't know what superposition is. So you should, if you're clear on your basics, then there is a good chance you might join in. And there are, for example, you are a BSc student, so you would have much more better opportunities getting internships in whether there are organized internships like Indian Academy of Sciences fellowships and BSRP, TIFR, and a lot of these things prefer people who are actually doing science in bachelor's. So first show that you cleared your basics properly, and then say that you read their papers. Of course, don't say that you understood completely. That would be a bit much. But say that, yeah, I'm interested in this area, and that is one good way of getting internships in academia. I'm not entirely sure how industry works, but I think if you show a bit of a coding skill, that I'm able to do this and I can write this amount of code, and then you show that, for example, a lot of these Indian companies, for example, Q knew that the quantum key distribution company, I think they are looking for people who are well versed in any of these quantum simulation languages, so Penny or Qiskit or some in this area, open source quantum simulation languages. So develop one skill and then run after. That is only way to get it, because it's extremely competitive. So you should be standing out for yourself, that develop one skill and show that you are good at it. This one discussion happened in our group, that how can you show that you did a course and you are good at it? That is to write a project and put a GitHub link. That would be an extraordinary way to showcase for yourself. So this you can do. And how to start off, that was another question that people asked, is to, one has to first of all learn enough quantum mechanics to know whether it is suited for you or not. A lot of people cannot digest or cannot even don't want to live with this nuisance for the rest of their life. So one has to know whether when you are able to comprehend quantum mechanics, and when not being able to do calculations is not enough criterion. That is a necessary condition, but it is not sufficient at all. So you should be able to be comfortable with this idea of a non-deterministic reality, and a lot of these ideas. I mean, not necessarily right away, but at least you should know that what you're dealing with. And one last thing I'd like to add is, read quantum mechanics, even the basic chapters. For example, you take Introduction to Quantum Mechanics, Griffiths. Okay, that is a self-sustained book. It's a self-sufficient book. Okay, you can read it on its own, whatever you are doing, and you open it and you can start learning it. So if you are able to go through 3 chapters and not want to pull your hair, then you are good enough to do set to do quantum computing. Or else because a lot of people jump into this because of the hype. And if you cannot survive, and if you are not able to live with these ideas of quantum mechanics, these are very weird. There is no reason why you have to be comfortable with this. So you should test yourself and know that you are comfortable, then only continue in the field. So the first thing I'd ask is read first 3 chapters of Nielsen and Schwang, Quantum Information, Quantum Computation. Literally, that is the name of the book. That is probably the first book written by 2 postdocs. No big shots, Nielsen and Schwang. And the second book is Introduction to Quantum Mechanics, Griffiths. That's all, the first 3 chapters. If you are able to go through them without, of course, with help, but not extremely uncomfortable, then you are good to go. That's all. Nothing more is required. Everything else is, there are huge number of resources that are available, and you should do fine. Yeah, I'm done.
All right.
I just
Thank you
have
very
a
much.
caution in that.
Okay.
Both the books, both David Griffiths and Nielsen and Chuang, they are, in my opinion, not well-written books. They
Even
both,
Griffiths.
even Griffiths, like even for a person who has not studied quantum mechanics, he will find, because Griffiths does not explain anything which can give you a physical intuition. He's more on the mathematical side, like all the first 3 chapters as well. What I'm trying to say is, these books, I have talked to a lot of people where people have said that Griffiths is very discouraging. And same goes for Nielsen and Chuang, because they do not have these
I could vouch for that in the sense that I was in my engineering when I first opened the Griffiths book and it had Schrodinger engineering equation in the beginning page. So needless to say, I was quite intimidated. But yeah, later time like got used to that. But I don't know if it's really the best book to begin with. But subsequent follow-up lectures or something, it should be fine. Because as from the index says, the foreword says, it doesn't teach you what quantum mechanics is, but it teaches you how to do quantum mechanics in his own words, by Griffiths.
Okay.
But like Ganesh said, you can start with watching the Qiskit Global Summer School first 3 days lectures. They're very good, and they will give you a good insight. You can watch NPTEL lectures. There's also lectures by Umesh Pazirani which are available on YouTube. First, go through them because they will help you develop a physical intuition. Then you go on to read these books. Because remember, I am from an IT background, but someone who has not studied quantum Turing machines or how automation works, the first chapter is very daunting. Like for many people, and these books have been the reason why people have left quantum computing in totality. So I will really advise not to jump directly to Nielsen and Chuang. Just do your survey a little bit, go through some lectures online, and then you jump to these books. Otherwise, you will be highly discouraged. This is what I think.
Yeah,
10
I
or
have a
11
recommendation
people have
book.
even messaged me. So that is why I will not. This is in my opinion, because Ganesh is also from a physics background, so he can understand most of the things. But someone who is starting from scratch, it will be very difficult for you to understand. Like if you just jump to this book. This is what I think.
Yeah, you're right with that. In fact, I have a recommendation, a book called David Quantum Computing, I guess. It's by David McMahon, and that's quite popular. Some 1 or 2 pros recommended me to start with that because it's a bit less intimidating. Anyways, if someone opens Wilson Chong and they're like, yeah, I'm cool with it, I'm doing that, go ahead. Like that will be the most time efficient way for you to go forward. But anyway, if that's intimidating you or feeling like some sort of disconnect or something, I would say you can start with this book called David McMahon. It's about 200 pages, I believe, or even much lesser. And you could finish it off in a week or something. And that should equip you with like probably the second chapter of Mr. Chuang, maybe at least half of that. And you will be in a position that you can like you don't feel intimidated with the language used over there. I mean, the algebra that's used over there, it shouldn't really intimidate you as such. So yeah, that's what I would say for someone who's feeling this thing is a bit intimidating. Maybe then you should go with David McMahon. Maybe there might be more of such books. I don't know. I'm not sure. But this one I got recommended by a pro. Actually, it's R. Srikanth sir, who's in PPR, Bangalore, I believe. So yeah. So anyone else here? Ganesh, would you like to say something?
Yeah. So okay. So okay, I can vouch with what Nakul said about Nielsen and so on. It is intimidating at first, but possibly the most comprehensive resource that is ever available for quantum computing. Even after it has been written, the first edition is written in 2001, and even after 20 years, that book is possibly the most comprehensive introduction to quantum computing. But it's intimidating. That I agree. And yeah, people get discouraged if you have a bad book or a bad prof. That I completely understand. One of the very reasons I hate quantum field theory is because of that. Okay. Fine.
I wouldn't call
So,
it a bad book as what you said.
Yeah. So it is intimidating. It's badly written. I agree with that.
Actually,
badly
I want
written,
I want to say something.
not bad. Yeah.
So actually, sometimes it depends on the background also. That if you have physics, if you have physics background, then you will find Ganesh will be good, and if you have CS background or engineering background, then Nakul opinion will be good. So it depends on what you are before.
That's fine. Yeah, that's what you were saying. Yeah, rightly said. And apart from that it's not really good to start off for a non-physics person, but Nielsen Chuang is standard book. It's the Bible. Like, I think you can find a foreword or something by Peter Shore himself saying that it's the most comprehensive book in quantum computing. So I guess that was for its comprehensiveness and quality and everything else. But yeah, you can start off with other books and all, but eventually you have to go through Nielsen Chuang from head to tail if you're really planning to pursue and stay in this field of quantum computing. So that's what I would say. So, anybody would like to add something or anyone else? I guess we're probably 1.5 hours long. It's already. Soumya, say something. You're not audible.
Hello.
Voice is cracking.
Hello.
Yeah.
Hello. Hello.
We can hear you now, Soumya.
Hello.
Hello. So there's some issue with us microphone. So anyways, anyone would like to say something? Like Richard Ghosh is here. Richard, hi. How are you doing?
Hi, yeah, I'm doing fine. I hope everyone else is safe here. So I'm so sorry I joined late. I actually had 3 interviews like today morning. So very sorry for that.
What are you interviewing for? Sorry.
I'm right now in my final year in CSE, so I'm sitting down for my placements.
Oh, okay.
So
I thought it was for one of the entrance exams or something. Yeah, please continue. Yeah.
No, not yet. I just started quantum computing in the around in the month of June, July. So I'm very interested in the sections relating to biology as well as in quantum biology, like especially bioinformatics side, since I started off with a bit of data science and cybersec. So as many of the mentors, like lecturers, have said that Qiskit lectures are pretty good to start off with. I personally found that that many lectures are there which are like Umesh Vazirani. It's not very well known, but he's actually quite good. You can actually start off with it. It was one of the main reasons he got me interested into quantum computing. So yeah.
Right. Thank you, Vishal. Umesh Vazirani lectures and many more lectures recommended throughout this discussion. Yeah, we'll actually be sending out the list, and you'll also get a recording of this call. Anyone else?
Rushant, this is being recorded, right? The whole session?
Yeah, it's all recorded. Yeah.
Okay.
So, anyone else would like to say something? We'll be closing it in some time because it's been too long, I believe, already.
Like there are various fields in quantum computing. I'll just quickly name them so that you can just not restrict yourself to this very particular thing that is promoted by IBMQ or any other company. There's not only error mitigation or decoherence control, which IBM currently is promoting like hell. They're promoting these two techniques very prominently, or even their own hardware technique that they use. There are other areas in quantum computing, like Ganesh, like the areas that Ganesh is working. So he even gave me a very good reference of open quantum systems. So you have open quantum systems. Then you have adiabatic quantum computing, a very famous model, but very less pursued as of now. But adiabatic quantum computing has proven to be very, very successful. In particular, D-Wave works on this model. Then you also have photonic circuits. So there's a company called Xanadu. They have a very good documentation. You can go to their GitHub page and or even on their website. So they use photonic circuits. So you can look at that. Ganesh mentioned Penny Lane. Penny Lane is a very good implementation of quantum machine learning algorithms. So that is also a part, I believe, of Xanadu. Then another very prominent field that is emerging. So in this semester, so I'm working with Professor Don Page and his students. So we are working on black hole information paradox, where we are trying to find out information from Hawking radiation. So we have like basically entangling. So we are basically working on entangling a set of qubits which are sent inside the black hole, and then extracting the information from the entangled Hawking radiation. So that is one field. Another field of application that is currently showing good progress in quantum computing is quantum neural networks. IBM Q is very frequently is picking up on that a lot. So you can work in that. Quantum cryptography has become very, very important, and I believe in ISI Kolkatta, as well as I think ISI Kolkatta, I'm not sure, they are working very, like, there are 3 to 4 professors who are working in quantum cryptography and error correction. So they are doing like a brilliant work. There are other models, but they might be too complex. One of them being topological quantum computing. It is a very new field, but it is mostly on the physics side, and a lot of geometry is involved. So you will need a decent amount of courses before you can venture into that field. So it depends a lot on what kind of background you should have before venturing into a specific field. Like if you want to go in error mitigation, like I believe Devanshi was working in, you do not need that much quantum mechanics. Just elementary introduction to superposition and entanglement is more than enough. But if you're working in quantum neural networks or even quantum machine learning, then you do need some approximation methods in quantum mechanics that are very frequently used. So it depends a lot on the kind of research that you will eventually venture into. But as a beginning, just watch some lectures like Rishabh has mentioned by Umesh Wazirani or by NPTEL, just elementary lectures, so that it gives you a physical picture of what is happening in quantum computing. Then switch to books. And Nielsen and Chuang is by far the best book, but I will not suggest that if you do not have a background in quantum mechanics, just don't jump to this book. Just have a little background from other sources, then switch to these books.
Right. That's it. And so anyone else would like to say something? I'll be sending a closing note. You can just come and introduce yourself. Just come up and mention where you're from. Okay, yeah. Soumya, do you have a good internet connection? Seems like it's a no. So yeah, I would like to give out a closing note saying that. So I would like to let you all know that whatever is happening here is, whatever people who have participated as speakers are, they're very benevolent in this, that they're expecting nothing, and they just want you people to learn things and benefit from their knowledge. And probably it's because they had a little bit of hard time in entering this field or starting with these things. And whatever, you will get a lot of support in this. Just you need to show some little effort in this, put in some work from your side, and you'll get a lot of encouragement because usually it so happens that people are just directionless. But here, if you have show a little interest and you could be guided really well by them, and these people are the ones, most of them here are they worked independently and they didn't have such support or something. Soumya was talking to me a couple of days ago, and he was saying that it was I guess he also mentioned in the talk earlier that it was really difficult for him to uh, work on this YTM thing and other things. Things have been loosened up a lot, and yeah, I mean, this is all they're doing for just for the sake of the pleasure out of seeing others taking advantage of their knowledge and making life easier for someone else. So, in fact, some others might be knowing, but same in Kolkata or somewhere, like I heard there are some uh, organizations or private organizations they're charging a bomb to do similar things that we are doing here. And I mean, but I mean, I just mean to say that this is something. Sorry, someone was. Yeah, someone want to say something. No, yeah. Anyway, so yeah, I'm just saying that this normally it's not something everybody has. That people actively working in research field are at your uh, help, and like they could help you at any time. Any minute you could just send out your questions or guide you or something. Because myself, when I had to get a project in this quantum computing, I had to go around a lot of professors, and they had the PhDs, and I don't know them, they're complete acquaintances, and so I had to cold mail them and arrange for a meeting because I wasn't really understanding much. But in your case, you're all very lucky in the sense that you have this thing, and I really want you all to take advantage of this, and you have more friends or someone who are interested, not just in quantum computing, but if you have other things also, you can probably start similar groups for other things. And I would encourage you all to actually participate in the group, and whatever your latest whatever you're learning at the moment are up, please keep us updated in the groups, so you people might be able to collaborate with each other and move ahead. Like, because having a small project or something that will kickstart a lot of things. Like, because basically, like, if you apply for a project or internship somewhere, they look for previous projects or internships, and getting the first one is the difficult part. Rest all will follow, as people were saying. So this could be your first place where you start your first thing. So I want you all to take advantage of this. Saying that, I would like to end the meeting today. Thank you very much, everybody, for being here with us. Thank you, one and all. It was a pleasure meeting you all. And I would like to thank all the speakers very much. Ganesh, Devanshi, Soumya, Rahul, and everyone else. Thank you very much. Bye-bye.